The heart of our solar system, the Sun. A massive, glowing sphere of hot plasma, the Sun is the most important source of energy for life on Earth. A giant ball of blazing gas. It dominates our sky, providing light and warmth. Without it, life as we know it would not exist. It is the source of our life, driving the weather, ocean currents, and the water cycle. The Sun's energy is crucial for photosynthesis, the process that allows plants to grow. But have you ever wondered how it works? How does this massive star produce such immense energy? Let's take a journey to unravel the mysteries of our nearest star. From its core to its outer layers, each part of the Sun plays a vital role. The Sun is much more than just a bright light in the sky. It's a giant engine, converting hydrogen into helium through nuclear fusion, releasing vast amounts of energy. It powers our entire solar system, influencing the orbits of planets and the behavior of comets and asteroids. Understanding the Sun helps us understand life on Earth. Its cycles and activity affect our climate and weather patterns. And it helps us learn about other stars in the universe. By studying the Sun, we gain insights into the life cycles of stars and the dynamics of galaxies. Imagine a giant onion. It has layers. Each layer is distinct and serves a different purpose. The Sun is kind of like that. It too has multiple layers, each playing a crucial role in its structure and function. It has different layers too. These layers are essential for the Sun's energy production and overall behavior. The innermost layer is the core. This is the powerhouse of the Sun. This is where the Sun's energy is made. Through nuclear fusion, hydrogen atoms combine to form helium, releasing immense energy. Surrounding the core is the radiative zone. Here, energy moves outward in the form of radiation. Energy from the core travels slowly through this zone. It can take thousands of years for energy to pass through. Next comes the convective zone. This layer is characterized by turbulent movements of gas. Here, hot gas rises and cooler gas sinks. This process helps transport energy to the Sun's surface. This creates a churning effect, much like boiling water. It's a dynamic and constantly changing environment. Finally, we reach the photosphere. This is the visible surface of the Sun. This is the Sun's surface. It's where sunspots and solar flares can be observed. It's what we see from Earth. The photosphere is the layer that gives us sunlight and warmth. Deep inside the Sun's core, something amazing happens. It's called nuclear fusion. This is the process that powers the Sun and gives it the energy to shine so brightly. Without nuclear fusion, the Sun would be just a cold, dark ball of gas. In simple terms, tiny particles called atoms smash together. These atoms are mostly hydrogen, the lightest and most abundant element in the universe. When they collide, they don't just bounce off each other, they merge. They combine to form a new atom. This new atom is usually helium, which is the second lightest element. The process of forming helium from hydrogen is what keeps the Sun burning, and this process releases tremendous amounts of energy. This energy travels from the core of the Sun to its surface and then out into space. It's this energy that we see as sunlight. Think of it like logs burning in a fireplace. Just as burning logs release heat and light, the Sun's nuclear fusion releases energy. The logs are like atoms. When they burn, they release heat and light. In the Sun, the atoms are hydrogen. When they burn, they release heat and light. This is similar to how hydrogen atoms in the Sun's core release energy when they fuse. In the Sun's core, hydrogen atoms are the logs. They are constantly colliding and fusing together. They fuse together to form helium. This fusion process is what keeps the Sun shining and provides the energy that supports life on Earth. And this fusion process releases the sunlight that warms our planet. Without it, Earth would be a frozen, lifeless world. The Sun's energy is essential for all life on Earth. The energy released in the Sun's core has a long journey ahead. It travels outward through the radiative zone. Then it moves through the convective zone. Remember the churning effect? This helps carry the energy to the Sun's surface. Finally, the energy reaches the photosphere. From here, it bursts into space. This energy travels as sunlight and heat. It reaches Earth in about 8 minutes, and it provides the energy that all life on Earth needs to survive.